Previously, we've discussed that the idea of utility maximization is basically the idea of consumer satisfaction maximization. So consumers make decisions based upon which bundle of products will maximize their utility. This maximization of utility is where we get our maximum willingness to pay for products. It's ultimately what establishes what we're willing to pay for products because it establishes what we expect to get out of products. When I make a decision to go to, say, a particular restaurant and I look at the menu and I see the prices of the various dishes and I see the dishes themselves with information about, say, how the product was cooked, what the actual product is, what are the ingredients of the products, all of this information, I'm able to very accurately make a determination that I believe that I'll get at least as much happiness out of the meal as would I get if, say, I didn't spend that money, or if I, say, took that money and spent it somewhere else, and even took, say, less money and spent it somewhere else. Idea that now I'm comparing more expensive restaurants to least expensive restaurants. I mean, if you think about the idea of where you should eat dinner, it becomes kind of a dizzying sort of decision, especially if you're lucky to live in a place like New York City, because there's just all these, you have expensive places and cheaper places and places that are close to you, places that require a long subway ride. I mean, there's all these determinations that go into ultimately what is a maximization problem, right? I want to maximize satisfaction. And it creates a willingness to pay, not just a willingness to pay for the actual price of a product, but how much time to spend undergoing a particular process. I may have a really, fancy restaurant that I like to eat at, but maybe it's on the Upper West Side, which is just too far away. I don't feel like going up there today, something like that. So it's not just about the price, although that's ultimately mostly what we talk about is the actual price of, say, the dinner. We can also think about the price of doing something includes the time it would require to undertake it. So this idea of maximization and this idea of optimization is on the surface simple, but it can get very complicated if we let it. So, the trick is to not let it get so complicated. So here's the utility function again. This is a particular utility function, just where the consumption of x1 and x2 yields utility that is equal to the product of x1 and x2 with the square root taken. Again, this may seem like a fairly complicated mathematical idea, but it isn't. We're just taking x1 and x2, multiplying those together, then taking the square root. So the actual math is very straightforward. And then the actual idea here is just that utility functions with respect to particular bundles yield particular levels of utility. And we can see that depending upon what we consume, we're going to get a particular level of utility. These numbers themselves are not very important. Saying that a bundle of 10x1 and 10x2 yields you 10 units of utility doesn't really say anything. In fact, it says virtually nothing in isolation. But if we compare it, say, to this bundle, we actually get something that's fairly interesting. So we see that if I consume 10 units of x1 and 10 units of x2, I get 10 units of utility, right? Remember, we defined utils as the units of utility. And then if I were instead to consume 5 units of x1 and 15 units of x2, I notice that I actually get a lower level of utility. Now, what's interesting about this is that if I think about this just in the context of numbers of units, this bundle and this bundle are equivalent. I'm consuming 20 units here, 10 of each, and I'm consuming 20 units here, 5 of x1, 15 of x2, and yet we see that this bundle here produces a higher level of utility. This is a fairly intuitive result if one considers that people often prefer to have variety, right? So one of the nice things about utility functions, and again, this is a specific utility function. I don't have to assume that people actually adhere to this, but it could be my decision to think that this is the way people behave. Then I can see that this particular utility function actually assumes a couple things. First off, that generally speaking, we see we have a very small bundle here. We see we have a fairly large bundle here. That we consume, rather that we get happier when we have more of the goods in our bundle. Well, in other words, if I have 10 units of each, I am quite a bit happier than if I only have a single unit of each good. So we like more, which again is a fairly straightforward and common sense idea in terms of satisfaction. The second one, which is perhaps not quite as straightforward, although I think most of us would agree fairly intuitive, is that not only do I prefer more, but I tend to prefer even amounts of two goods as opposed to extreme amounts of either of goods. So, for example, 10 units each of the two goods yields me 10 units of utility. However, if I only consume 1 unit of X1 and I consume 19 units of X2, I see that my utility is considerably lower. Because I'm consuming so many X2, I'm falling prey to diminishing marginal returns. Absolutely. And so the basic idea here is that not only are utility functions simple, right? I just plug numbers in, they give me levels, but they also can be constructed in such a way that they actually create fairly intuitive outcomes. If you think back to the second lecture where we talked about this idea of heuristics, we create frameworks for understanding how people make decisions. Utility functions are strong because they're simple, but they're also strong because you can construct them in such a way where they actually behave the way we tend to think humans will behave. So I just think this is a fairly interesting result that comes from what ultimately is a fairly straightforward utility function. All right, so previously we've just defined the idea of marginal utility, which is just the change in utility divided by the change in consumption of a good, here X1. This tells us the extent to which consuming additional units of X1 increase our happiness or increase our utility. And again, this is a part of that thinking on the margin. We've discussed in class how, regardless of whether you're a baseball team in the context of the movie Moneyball, or whether you're a student deciding how much you should study versus how much Netflix you should watch, that basically we want to often think about these problems in the context of marginal or incremental changes. So how many hours of studying versus how many hours of Netflix is perhaps a better way to think about studying versus Netflix than should I simply study or should I simply Netflix. So in a sense, it allows us now to have an optimization problem, to actually have a problem to solve if we think incrementally. And so in the context of Moneyball, this was, okay, which particular statistic do we want to maximize? In that context, they wanted to score as many runs as possible each game, so ultimately they tried to maximize on-base percentage because they figured that if you maximized on-base percentage, you would therefore maximize runs scored each game. And we saw that it was fairly successful for them. So here again, we're just kind of thinking on the margin. And here we have a same utility function as before. And what I'm doing here is I'm holding the consumption of X2 constant at 10 units, and I'm simply increasing the consumption of X1. And again, it's the same utility function. I'm just plugging these numbers in, and I'm just looking at my behavior of utility. And a couple things I think should sort of be pointed out here. First off, again, this is fairly simple mathematics, so regardless of whether this looks complicated, notice that we're just plugging numbers in. So, nothing necessarily to be afraid of, but also notice how instructive this is. So this is the different levels of utility that I experience with these particular bundles. I see that as I increase my consumption of X1, as I would expect, my utility is rising. And notice that this allows us now to actually get at marginal utility of X1 given a particular level of X2, which is in of itself a fairly interesting sort of conversation to have, especially if X1 and X2 are related to each other. If X1 and X2 are completely separate, like for example, if X1 is blue jeans and X2 is computer monitors, then they have nothing to do with each other necessarily, and so therefore their relation in terms of utility going to have nothing to do with each other. But we'll see in a few moments actually that X1 and X2 could be related in a number of different ways. For example, X1 could be computer monitors and X2 could be computers. And so in fact you will often see these two goods consumed at the same time. And so therefore the marginal utility that they have for each other will actually in some cases be related to each other. And so it's interesting to kind of see sometimes these sort of scenarios where you can hold one level of the good constant, here X2 being held at 10, and then you can kind of see what happens as you consume additional units of X1. Of course, what we're more interested in than just utility is we're interested in marginal utility. And we can see that marginal utility is falling. So in other words, as I consume additional units of X1 when I'm consuming none, I can see that my happiness rises considerably. But then as I continue consuming additional units of X1, I'm still happier. My utility is rising, but my utility is rising by less than it was. So incrementally, it's actually going down. We see this behavior here to the right. This is simply utility tracked relative to x1, again holding x2 constant. And again, we see a behavior where utility is rising, but it starts to slow down. Mathematically, we would say that this is increasing at a decreasing rate. So it's going up, but the amount that the function is going up is getting less and less and less each time. Again, diminishing marginal returns. You'll see this show up a lot. Okay, so the idea here is just as I consume additional units of x1, my marginal utility is falling, despite the fact that my utility is actually rising. So again, it's just another way for us to see that these utility functions can have very intuitive outcomes. We already believe that diminishing marginal returns is a thing, that in fact, as I consume more of a good, the extent to which increasing my consumption of that good yields me happiness, we actually expect that to fall. We can see that this particular utility function, in fact, creates that exact scenario. So again, this is kind of the beauty of utility theory as an underlying concept.